Hired, the leading career marketplace for software engineers, will match you with your next job. Based on your skills, experience, and desired salary, they'll intelligently match you with over 10,000 companies who are looking for engineers just like you. Better yet, you don't even need to apply. Just create a profile and let leading companies such as WeWork, Dropbox, Wayfair, Zillow, and more apply directly to you. Join Hired today at hired.com/HanselMinutes. That's hired, HIRED.com/HanselMinutes. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Preethi Kasireddy. She is the founder and CEO at TruStory, and she's worked at Coinbase, and she worked on Socket.io, partner at Andreessen Horowitz. You've done all kinds of great stuff, and now you've started a new adventure.
Mm-hmm. Thanks, Scott.
Yeah, thanks for coming on the show. I wanted to talk to you about, and this is going to be kind of open-ended, so help me with this, like the blockchain for regular people, for like the people who are listening to this show. We kind of get the tech, we kind of understand, but maybe we feel like there's something we don't understand because we're not as excited about it as maybe we should be, or as some of the people in the community are.
Yeah, sure. I mean, happy to explain any questions that you have. I think like the one thing I want to correct you there is like blockchain is technology, sure, but it's also a narrative and a new kind of like story and way of living that people want to believe in. So I would say like we should look at it from both angles.
I appreciate that.
Yeah.
That's interesting. Okay. So you're saying that I may be trying to put it into a box and make it smaller than it is.
Yeah. Like, I mean, before the show, you mentioned something about potentially it feeling like a cult. And that's right. It's like blockchain is technology. Sure. We created a whole new way and primitive for achieving a distributed ledger without a central party. That's the obvious. But then what that enables is kind of this like story that you're buying into, which is like decentralization, censorship resistance, like freedom from like governments, things that like properties that people care about and narratives that people want to believe in because they are trying to fight against the centralized evil governments and banks.
Interesting. Okay, so let's unpack that because there's a lot there. Are you saying that we say that technology is by its nature political, like one cannot be apolitical and also be a technologist, but you're saying that there is a life philosophy and a political philosophy behind it such that blockchain represents freedom from something that is undesirable so that people who are of a like mind are flocking to the technology because they also have that shared belief system.
Yep, you said it exactly how I should have said it, but that's absolutely right. If you think about it, like the history of Bitcoin, right? It was kind of invented around 2008, 2009 era. And that was around the time when the financial crisis was happening. Things were not going well in the economy. People were starting to lose trust in existing systems, whether that's governments or banks. And really, I think that the primitives that were needed to make Bitcoin happen have existed for decades prior. And I can share a very good blog post that highlights all the things that actually existed before this. But it was a timing that was just like perfect around that time when there's just a lot of loss of trust amongst, especially like libertarians and people who were seeing what was happening. And Bitcoin came along and was like, hey, look, like we can build a trustless system to manage our money. And like that really like resonated with people because it was solving a fundamental problem that people felt like that they had, which was they didn't feel like they can trust governments and banks.
Interesting. Melanie Swan authored a book called Blueprint for a New Economy. Like it just says blockchain, blueprint for a new economy. Like you went from like a technology buzzword to like, and let's talk about how we can restructure like humanity itself. It got big fast.
Yeah, exactly. And like what fundamentally attracts a lot of us to at least in the beginning, what attracted a lot of us is that, yeah, the technology is cool. Like it's really cool understanding how Nakamoto consensus works, how proof of work works, and seeing all that. But what it forced a lot of us to do is kind of let go of the ignorance that we had of like how current systems operate. Like when things are going well, you don't really try to understand how those things work. But
Hmm.
when things are not going well, like then you're like, why isn't this working? And so it forced a lot of us to go back in history and read about these systems, how they were put in place, like why they were put in place, and figure out like, okay, is there a better way or and a new way to do it? And I think like fundamentally my thesis is that that's why there was a lot of hype around blockchain, is because it was like this revolutionary new way of living and doing things.
Hmm. Is that something that one has to buy into? Like sometimes when SQL Server came out, or entity relationship diagrams, I can't remember a time. Maybe you can, when there was a technology that came out other than the internet itself that got people this amped from a geopolitical philosophical perspective. Like, I guess what I'm saying is I cannot think of something that is that big. And do I have to, if I want to
Yeah.
use it, I could just say, well, I'm going to use some blockchain in this project, or do I need to buy into all of the philosophy behind it?
I think like I would say it is, if it works, it does have the potential to be the not the new internet, but as big or important as the internet. And it's because like fundamentally what we're trying to change is how humans interact
Hmm.
in financial and economic like economies. And that's like huge. Like that's billions and billions and billions of dollars worth of interactions that we're trying to change. So yeah, it has the potential to be huge. But I think like I'm not going to say that we're anywhere close to that. Like the narrative is way further out than the actual like where we are in terms of real technology and people actually using it. So there's a lot
Mm.
of catch up that we have to do to meet that like narrative that seems to be in the air about what this thing can do.
Well, that brings up an interesting question then. So, from a technology perspective, for those of us who are listening who maybe have, Googled for blockchain, but we haven't actually done anything with it, are we at version 0.1 as this like an emerging thing, or has something been achieved where it's like, all right, it's 1.0 and it's ready to go big? Or is it, like you said, really still being evolved and being actively developed?
We're in very early days. It's kind of like when the internet came out and like you can barely store like two songs on your computer or something. Like it's funny because like humans just history doesn't repeat, but it rhymes. Like I was reading a book about like how the internet happened, and it just feels exactly like the early days of the internet. The today in the blockchain world, like things are incredibly slow. The blockchain can't store anything large. Like transactions happen once every 10 minutes on the
Hmm.
Bitcoin blockchain, a little bit faster on Ethereum. Like it's just like it just feels like in so early.
Hmm.
But I think like what's interesting is like humans always overestimate what they can do in the short term, but underestimate what's possible in the long term. So what you
Mm.
see is like we had this overestimation of what can happen in the next like over the last couple of years of like what this thing can be, but then like people started to reach like their limits, like things were falling, things were not scaling, blocked, like the ICO boom happened and completely fell apart, all the altcoins went to zero, and then now everyone's like kind of like totally underestimating what's still possible in 10 years.
Hmm.
So I think like the builders are still building behind the scenes, but yeah, we're totally in the early days. And I think like before we see anything like really big and meaningful, it'll be at least like another 5 years.
Mm. It's interesting that you talk about how there was kind of like a little mini crash there. I remember where I had relatives calling me and saying like, I should go to Coinbase and sign up like immediately. This is the boom. It was like a little boom, and it feels like it only lasted a couple months. And then basically we the great unwashed, the regular people kind of said, oh, well, this didn't happen. I didn't get rich. My Bitcoin's not worth anything. And then we stepped aside. But to your point, the true believers are working hard to move this forward.
Yep. Yeah. And like if so like Twitter gives you a false illusion of like sometimes what's actually happening behind the scenes. Like there's actually a
Hmm.
lot of teams that are not public on Twitter and like shilling their coins, or Bitcoin maximalists who just like try to say like they have like very like strong views and almost like uh yeah, there's so much happening behind the scenes that's not on Twitter. And so I think like sometimes people have an impression that crypto Twitter is blockchain, but like that's not true.
Well, as with all cultures, there are cultures and subcultures within them. But most people just want to do good work and they want to use the right tools for the job. Where do we start when we're thinking about, like, I have a technology problem and I'm not sure if I should use some blockchain app platform to solve that problem?
If you're asking that question, you probably don't need it.
Wow, that's an awesome answer. Actually, I appreciate that.
Yeah, like I'll be honest. Like, I mean, I think like that's the mistake we ran into in 2017, where everyone thought that like they needed a blockchain, and then like they shoved a blockchain into stuff that didn't need a blockchain, and then now we're in 2019 and realizing that a lot of these projects didn't need a blockchain to start with.
I
And
feel like that
so
about like MongoDB for a while, or like document databases.
yeah, so I think like let the builders, if like, yeah, let the builders kind of keep building and like make the use cases more obvious. But it's not, if it's not obvious to you why you need a blockchain, then you probably don't need it.
Okay. So what is an obvious thing that would cause me to go, yeah, of course, I didn't even need to ask the question. Yes, there's no other way to solve this but with blockchains.
Like, I would say if you're trying to build a system where you're trying to coordinate a bunch of people to do something without a central party. So you want the system to be decentralized, and you don't want a central party to be made. Like, you just want people to coordinate amongst themselves.
Mm-hmm.
That's when you probably can use a blockchain. And an example of that is any kind of, basically like Bitcoin is an example of that. And the reason that's an example is because you have a system where there's no central party, there's no bank, but you still have all these people coordinating to achieve a common goal, which is to have a censorship resistant money. So it's usually like you're trying to just coordinate a bunch of people to achieve a common goal, and you want it to be decentralized. Like, now, like, when does something need to be decentralized and when does something need to be centralized? Like, this is something, honestly, that as an industry we're still trying to figure out, and we're actually still trying to figure out, like, where does decentralization actually make sense, and what things should still be centralized, because there's no perfect answer. It's not like everything should be decentralized and everything should be centralized. And so I would say we're still in early days of figuring that out.
Mm-hmm. Hey, folks, I hope you're enjoying this podcast. You know, I've done over 650 podcasts, so I must enjoy doing it, and I hope you enjoy listening. But if you enjoy stories about the people behind the technology you use, you should also check out the Greater Than Code podcast. They focus on the human side of software development. They've got stories of inclusivity and accessibility from the people you don't normally hear from. Search for Greater Than Code in your favorite podcast app, or check out greaterthancode.com. I hear the word trustless a lot. Like, if you're in a situation where you want to do something and you really can't trust everybody, even and the people involved may not even trust the centralized place, like a distributed Kickstarter would be a reasonable use of a blockchain.
Yeah, like fundraising in a distributed way, I can totally see that. Another example might be like a YouTube. I can imagine like content creators and then people who want to pay for that content wanting to all just do it without like a central party taking some kind of cut out of that. And yeah, like I think like I think, yeah, like we'll have to see what use cases come out of this. But right now, the application level use cases are not really as prominent. The main use cases right now for blockchain are basically money, like a store of value, which is like Bitcoin. Like, you just buy Bitcoin, you hold it because it has some value. And then we're starting to see early use cases where people are trying to use cryptocurrency for things like collateralized debt, and other financial assets. But again, we're in very early days of that.
Okay. What is the difference between, I understand Bitcoin as this is a stored value, and it's the one that is fun to say. It's the one that feels good in our mouth. Bitcoin's fun to say. It's the one that always gets on the news. And then Ethereum, which I believe introduces this concept of a decentralized virtual machine. And I keep hearing about Ethereum as a distributed computing platform.
Yeah, that's correct. So Bitcoin obviously was founded, it was the first cryptocurrency. And one of the visions that was outlined in the Bitcoin white paper was that people can build applications on top of Bitcoin. like decentralized applications. But Bitcoin did not make that easy. So the scripting language for Bitcoin is basically almost like writing assembly, and that's not very developer friendly. So then Vitalik and the Ethereum founding team came along and were like, we're going to create something that is much more favorable to building applications, not just have a currency, but also have other applications be able to be built on top of that.
Hmm.
And so, yeah, you're right. Ethereum is kind of like a distributed virtual machine in the sense that it still has the a consensus engine. It's a blockchain. There's transactions, but what it also has, in addition to what Bitcoin has, is that it has a smart contract language that looks similar to JavaScript,
Hmm.
where you can actually code quote unquote smart contracts, which are like basically self-enforcing rules. And so you can use these self-enforcing rules to build any kind of application. And that's really the difference between Bitcoin and Ethereum. Um, and you can probably go online and see some of the early applications of what people have tried to do on Ethereum. Things like one of the earliest successes was CryptoKitties, where
Hmm.
people tried to build basically virtual goods on Ethereum,
Hmm.
and that was an example of an application. Now people are trying to. For example, something called Pepeth, where people took Twitter and tried to build a decentralized version of Twitter on Ethereum. It's actually pretty cool. So yeah, you're starting to see early use cases, but a lot of these just feel like toys right now,
Mm.
and no one's like using them at scale.
Okay, so these smart contracts that use the Solidity language
Yep.
that sits on top of Ethereum, is this general purpose computing? Like I can do computing of like ask questions that are not related to transactions and contract, or is this primarily about elevating standard traditional contract law into an enforceable way that lives inside of a blockchain?
No, it's so I think like calling it smart contracts was a huge mistake,
Hmm.
because they're not they're not technically like legal contracts. Like when you're writing a smart contract, it's basically just like you would write code. There's functions, there's if else statements,
Hmm.
there's adding, subtracting numbers. Like
Yeah, it's a
it's
Turing
basically
complete thing, right?
yeah, it's a Turing complete language, and and it's not necessarily like a legal contract.
Hmm.
And so I think like calling it smart contracts is wrong. That's why I actually prefer to call it like self-enforcing rules, because like
Hmm.
once you code the contract, it enforces itself because it runs in a decentralized way and it's being managed by the blockchain.
Okay.
So you define a set of rules in these smart contracts. For example, a rule might be that every day I pay Scott Hanselman 10 cents on the blockchain or something,
Okay.
and
I like
that's
that rule.
and that rule gets enforced by itself because the blockchain is validating that contract and making sure that transaction happens.
Okay. So let me dig in a little bit and show my ignorance and hopefully help the audience as well. So where is this running? Are we all running agents in the background on our machines? Is the blockchain a bunch of us running bots and little processes?
The blockchain, you can think of it as, just to simplify,
Hmm.
think
Please.
of it as a spreadsheet. Okay. And the spreadsheet has all the transactions from day one that happened on it. And every time you update that spreadsheet, everyone else can see that update.
Okay.
And everyone's maintaining a copy of the spreadsheet. So think of it as like Google Sheets, basically. Every time you change something, I can see it. Every time I change something, you can see it. The only difference is that every change in that spreadsheet has to be approved by everyone.
We all
Um,
agree. We all
we
trust
all,
it as a
yeah,
group.
yes, we all have to agree on that change. And the way we agree is by, that's what the consensus, quote unquote, consensus algorithm
Hmm.
does, which where a bunch of miners are incentivized with tokens to compute something and make sure that that's a valid transaction. And then if it is a valid transaction, they get the authority to add it to that spreadsheet. And then everyone looks at it, updates their own spreadsheets, and they're like, okay, we added this transaction, let's move to the next one. And so we're all collectively together working to update this spreadsheet and agree on it over time.
Okay. So then in the example where you said that there was a contract or a bit of code that's paying me 10 cents every day,
Yeah.
is that running in multiple places and it's happening multiple times and being agreed upon multiple times?
Yeah. So there's a smart contract, right? And it has this code, and the contract says that like Preethi sends Scott 10 cents. So that's a transaction. And that because of the smart contract, as soon as the smart contract is invoked, that transaction gets executed. And then now to add that, to make sure that transaction gets added to the blockchain, all the miners verify that transaction, they approve it, and then it gets added to the blockchain.
Okay, so it's the acknowledgement that it had happened and the agreement that it happened and it's okay and it's been added to the chain that is distributed, but the actual running of it is not necessarily happening like everywhere. Is it happening on a random person's machine? Like
No, no,
who's
no. The running of it happens everywhere too. Like everyone's maintaining the same VM.
okay. So everyone's running the same VM. Then are we all running everyone's code always, all the time?
Yep.
So then how does that, and this is, forgive me, I felt this was going to be bad before I said it. How does it scale? Does that not mean that there is a finite amount of compute available, which is the Cartesian product of all the different people involved in the chain?
That's right. It doesn't scale.
Oh, okay, good. Then it wasn't a dumb question.
Yeah. I mean, like I wrote about this a year ago, and I think like we started to realize this about 2 years ago when we created this thing, but then we realized that when you put everything on the blockchain, it doesn't scale. And there's only so many transactions that can happen in a minute or in 10 minutes.
Mm-hmm.
And beyond that, like it just creates bottlenecks. And a great example of this is what I mentioned earlier. There was an application called CryptoKitties, which like went viral, and people were trying to buy these CryptoKitties, but then like it completely clogged the network. And Ethereum just like basically almost like broke Ethereum because like it just couldn't handle all those transactions.
So you're saying like literally meme cats, like
Yep.
cute pictures of cats brought down the chain.
Yep, exactly.
Because people like cats more than other things.
Yeah. The internet loves cats. But yeah, that was kind of the moment of realization. I mean, a lot of us in the background have known about the scalability problem for a long time, but in the public side, that it wasn't a very obvious problem.
Mm-hmm.
But when CryptoKitties came along, it finally rang the bell in everyone's head. They're like, oh shit, like the blockchain is not scalable. And that's when people started to explore. That's when there was like the proliferation of alternative blockchain. So now scalability was a big problem and everyone had to solve it. So then you're seeing like tons of different ways of solving it.
Mm-hmm.
And there's like tens of different blockchain projects that are solving it in different ways. There's EOS, there's Ethereum with its own solution, and Tezos and Cosmos, and I can go on forever. But so that's one approach. People are either like trying to find different trying to like invent a new blockchain that solves the scalability problem, or the other approach is they're moving to what we call layer 2, where they're trying to build solutions where a lot of the high volume transactions happen off the blockchain, but they only go to the blockchain when they need to settle or when they need to dispute.
Interesting.
Yeah. What I said earlier about different blockchains trying to solve the scalability problem, that's layer 1, meaning like it's the blockchain layer that you're trying to add more scalability to.
Mm-hmm.
Or you can go layer 2, which is like above the blockchain, and it doesn't ever touch the blockchain, but only hits the blockchain if they want to settle or dispute.
Interesting, which is a classic computer science thing. If you have a problem, well, we need to add a layer of abstraction to get rid of that problem. And in this case, we're kind of dereferencing the pointer and moving everything off of the bottleneck, and we'll just run it locally on our own machines. But then you have to figure out which part do you trust, which part do you not trust.
Yeah, and this is a whole another problem because like now you're going to layer 2, and so you have, for example, one example is state channels. And the state channel is basically two parties are sending transactions to each other. So let's take the Scott Hanselman and Preethi example where we're sending 10 cents to each other every day.
Mm-hmm.
So we just create a state channel together, and we're sending 10 cents to each other every day, but we only go to the blockchain when one of us wants to either cash out or if like we want to dispute because you didn't send me the 10 cents. And so that the only time we go to the blockchain is when we need to like fix something or cash out. But the problem with that is like we haven't really figured out an efficient way to do that, because like the proofs that are required when you go back to the base layer, to the layer one, you need like efficient ways to calculate proofs
Mhm.
that like this happened, and the efficiency there is not there yet. We're still like several years or months away from getting an efficient way to do that.
Yeah, well, it sounds like layer two would then allow you to do like recurring subscriptions and loans, and you and I could have a year or more worth of interactions on that layer and then never actually hit layer one. But then when we do hit layer one, we got to start asking ourselves all kinds of hard questions about, did we even trust each other over the last year of interactions?
Yeah, exactly. And then this brings the question of like, you know, it brought up an interesting question, because okay, if we're doing a lot of these stuff in layer two, then it made us rethink about what actually does have to exist in layer one. Because like we started off with putting everything in layer one and realized it's not going to scale. So now we're like, okay, can we move things to layer two? But then like now we're like, okay, like if we're moving to things to layer two, like what does it mean? Like what actually should exist on layer one?
Mm.
Like because like we know that blockchain doesn't scale. We know it takes a lot of work to secure the network. Like miners have to expend all this either energy or money or power to keep this blockchain secure. So like if we're going to spend all that money to keep it secure, let's make sure that we're only storing in there what we really need to store, and not like necessarily crypto kitties, right? Like do we really want to store virtual kitties on the blockchain? I don't know.
Mm. And that's such, from a computer science perspective, that's such a funny thing to me, because we're always moving up and down the layers, trying to figure out the right thing. You know, video card device drivers should belong in the kernel. Oh wow, video card device drivers can crash an entire computer. They don't belong in the kernel. They belong in user space. Well, there's performance issues if we move, and we just go back and forth. We're watching the internet itself and the blockchain kind of refactor and learn, and as the community tries to solve the problems that they planned for, and then the problems that they never expected that they would have.
Yeah, exactly. And I think it's totally. And if it's so funny, because like the same problems, humans solve the same problems over and over and over again. And sometimes it would help if people would just like read about how it was solved in other areas or in the past, because I just don't think people are as good at learning from history as they should be, especially when it comes to technology.
It's funny that you mentioned that, because I am, as someone who has been doing software for 27 years, almost 30 years, I don't want to be the old person that says, hey, we did that before. But I do see a lot of really amazing people in their early 20s with a lot of great energy
Yeah.
building stuff. And I don't want to be a gatekeeper, and I don't want to be a hater, but I do want them to crack a book and maybe explore some of the problems that were solved in the 40s and 50s and 70s.
Oh yeah, totally. Like especially in the, I mean, you see this especially in the JavaScript world, where like people love to reinvent the wheel, and you're like, this was solved. There's people have thought about this for decades.
So you're using this at TruStory.io, TRU story.io. You're building a social network to try to identify what is true and what isn't.
Yep, that's right. And we're building part of it in a decentralized way and part of it in a centralized way, and I can explain. So as you said, we're building a platform where we crowdsource the validation of claims that people make on the internet. And so we're starting specifically with claims in the cryptocurrency space, but then moving to other categories of information as well.
Mm-hmm.
And the reason we are building our backend on the blockchain is because we do the way we validate these claims is we have a token incentive where people are putting their skin in the game and incentivized to validate these claims. And so we, instead of us managing those tokens and that protocol, we want it to be self-enforcing
Mm-hmm.
and decentralized. And so that's the layer that sits on the blockchain. the rules that govern how the validation happens sits on the blockchain, and then we're building APIs and an application that's more centralized that provides the user experience.
I'm getting kind of a Snopes meets Quora with skin in the game kind of a vibe out of this.
Exactly. You got
Interesting.
it right.
Okay. So someone could theoretically game it, but if they were trying to do that, it would cost them a great deal if they were trying to like convince me that the Earth was flat on TruStory.
Exactly. It would cost them a great deal. And like just like any decentralized system, it works under the honest economic majority. So I won't really go into the detail of how the incentives work, but like how at a high level, like you are staking and then you're earning reputation over time for being right. And so we disincentivize people. Like, let's say tomorrow a state actor wants to come in and buy truth. Like, that's just not possible because they have to earn reputation on the platform, which takes many, many attempts before they can buy truth per se. And by that time, that person is a high reputation user, and like everyone's already watching that person.
Very cool. Well, I wish you all the best, and I'd very much appreciate you hanging out with me today and helping me get my head straight around blockchain, around Ethereum, about the future. It sounds like an exciting future indeed.
Awesome. Thanks, Scott.
We've been talking with Preethi Kasireddy from TruStory, and this has been another episode of Hansel Minutes, and we'll see you again next week.